I hit the wrong button, that's why. Alright, cool. And we're live. Alright, so today we have ourselves a MacBook Pro A1990 that's not turning on. I haven't really spent much time looking at this computer other than we know that it doesn't turn on. With everything completely unplugged, I think we get 20 volts on all ports, but let's just go ahead and kind of test this one from the get-go. I don't have my normal multimeter software that I use for the one eye attachment, so we're just going to have to rely on our Fluke 115. So the first thing we want to do is go ahead and make sure our battery's unplugged so that we can get a proper amperage reading. Because when the battery's plugged in, we're going to be consuming more amperage with the battery circuit actually charging the battery. So let's see what we get with the battery unplugged. So on this port we're getting 5 volts at 0 amps and spiked up to 0.02 and just went back down to 0. And it looks like we're back up at 0.01, so we have a little bit of pulsing on the bottom charge port right here. Let's go ahead and plug in our USB-C ammeter up here at the top, see if it does anything different. Basically want to check and see if any of the USB ports act different than any of the other ones. Because if this is a charging chip issue with one of the CD32s, usually it's the one that is acting different than the rest of them. So this one is also getting about 20 amps or 20 volts, and we're also pulsing with our amperage from 0 to 0.2. So that is in line with the USB-C port right here on the bottom side. Let's move over to the left side and see what we get. $20 volts, 0 amps, 0.02. So this one is also doing the same thing. And then let's check this last port. Now, before deeming this to be a board repair, we did hook this up to Apple Configurator just to see if the device was stuck into DFU mode, device firmware upgrade mode. Sometimes the T2 chip here can act up with the firmware and lock up the entire computer. And that is not the case. So this port is doing the exact same thing, 20 volts at 0.02 amps. So now we're at a point to where all the USB-C ports are doing exactly the same thing. So there's not one port in particular that's really jumping out at me. And the fact we're getting 20 volts and then nothing, usually that is going to be a short on PP bus. So we're going to go ahead and measure for any obvious short using our multimeter. So what we'll want to do is put our multimeter into continuity mode. Get this into the view so you can see. And we're going to probe our PP bus, which is going to be these two fuses. I know it's a little hard to see with the overhead camera, but I have these two fuses that we want to measure. And if they are shorted, we'll have a beeping noise, kind of like that. But let's check and see. And no obvious short on our PP bus line. Let's go ahead and put this, measure what the resistance to ground is. And we have infinite resistance. So PP bus isn't obviously shorted. So the next thing I want to do is visually inspect this logic board. So we're just going to go ahead and pull the logic board out, put it underneath the camera, maybe even hook it up to our thermal imager and see if there's anything that jumps out. Although the notes that one of my technicians left here is that there's nothing obvious on the thermal imager. So there could be a short, but not until further on down the line of the boot sequence. Fortunately, this logic board, most of the screws have already been removed, so we only have 2 screws that are holding the rest of it in place. Of course, when doing this, make sure that you have your battery unplugged. You don't want to unplug your screen or other components with your battery still plugged in. And let's get our handy dandy T4 screwdriver from our iFixit toolkit. And is this the type? Yep, we need to peel back these rubber gaskets that seal the fan down to the heatsink. And let's pull the board out. This one, I don't really have an idea yet of what we should look at. So let's see if there's anything visually wrong with it. And first, I'm just going to give this a quick visual inspection before I put underneath the microscope, just to see if there's anything obviously damaged. And I don't really see to the naked eye anything jumping out at me. So now, let's go ahead and put this underneath the microscope and check and see if there's anything a little bit more hiding in finer detail. So let's get this focused. Make sure it's focused up there. Looks like it is. Perfect. And let's just work our way down. So this one actually has a CD3215. This was actually one of the last T2 computers that had a CD3215 before they transferred over to the CD3217s that have more firmware programmed into them than their CD3215 counterparts. I personally like working on machines with CD3215s because the custom CD3217 they started using has weird firmware compatibility issues on some Macs. So we shouldn't have to worry about that on this model. So searching around here on the back side of the CPU, GPU area looks pretty clean. There's just obvious signs of dirt and dust. But that's how MacBooks work. They're vacuum cleaners. They pull in cool air and blow out hot air. It's very, very faint, but we have a little bit of corrosion right there. That one capacitor, we can see that test pad. See a little bit of green stuff right there. So we'll make a note of that and revisit that here in a moment. But that could be because that's close to the intake, where the computer sucks in air in order to blow hot air out. And on this side, don't really see anything else. So now, before we inspect to see what that capacitor is, or what it's connected to, let's look on the other side. So now I have the board upside down. So this is going to be where our Touch ID plugs into. And we're going to work our way down the board. That is going to be our SSD power supply chip. This is known for going bad on 16-inch MacBooks, but it's not impervious on this model. And it is on the direct underside of where that corrosion was, so we'll want to make sure that the SSD power supply chip is working. Okay. We're looking around the power supply, or some people call it the PMIC for the T2 chip. Going around the processor. So far so good, don't really see anything. Okay, around the CPU, GPU area looked pretty good. And now let's look on the other wing of the board. There's our audio circuit. Looks okay. And here's our other CD3215. Okay. Well, to the naked eye and underneath a microscope, I can't really see anything obvious outside of that one little capacitor. There was some buildup, looks like maybe humidity buildup. We're going to pull this up on a schematic and check and see what that's connected to. But first, we're going to need the board number off of this guy. And the board number for this one is 820-01041. So let's find that software on our board view software. And let me put this up in stream mode so you guys can see what I see. There we are. And this is a previous board we were looking at, so now we need to go back to this specific model. So which one we say that was? It was a 01041. Do we have the schematics for a 01041? We do. So let's go ahead and pull up our board view software here. All right, so this is our board, this is our schematics. I've inverted it just to be easier on my eyes. So let's check and see this capacitor on this side. So it was C9081, which is PP bus SSD. I don't think that's it. I don't think that's going to be our issue. And the reason I say that is because our PP bus isn't shorted when we measure to ground, and also with continuity mode with our multimeter. So just in good measure, let's check anyways. So I'm going to put my multimeter back into resistance mode. Let's go back into our microscope camera here and check and see what we have.
Yeah. Did you know they make laptops for those? Yeah, there's...
Yeah, and we're in the 7 mega ohms. Sorry, I don't have my multimeter software working right now. I have my other multimeter at my home office. So that doesn't appear to be the issue. However, what is this test point that's right next to it? Because this test point, if there was humidity buildup, could have bridged this test point to the ground on this side of the capacitor. It's still in the mega ohms, but let's now find out what that is on the actual schematics. And that is our 2.5 volt NAND SSD-O. This is going to be the 2.5 volt line that actually powers our SSD. So hopefully this is okay. Although when I just measured it just now, I think it said 3 mega ohms. Yeah, we're in the mega ohms. So hopefully this didn't cause a short at one point and kill the SSD. But so far, no obvious signs of shorts on both PP bus and on the... Whoops, wrong camera. So far, no short on PP bus or on the SSD line. I think this is a silly idea, in my opinion, to have this line so close to the SSD test point. But I digress. So now, let's go ahead and just hook it up to our thermal imager. I get comments all the time where people are saying, you know, this would be a lot faster if you had a thermal imager. We do have a thermal imager, but sometimes I try to do things the long roundabout way so that other people who don't have an $800 thermal imager can check and do things at home or at their repair shop with the tools that they have as well. So let's go ahead and hook up. Our thermal imager is actually already hooked up, so let's go ahead and turn on our thermal imaging software and go back to our on-screen camera. Okay, and let's pull back up OBS. I just kind of lost everything. Here we go. So you can kind of see the outlay of the board here, and I actually have it in seek mode. We don't need that anymore. And let's see if anything immediately jumps out at us whenever we turn this on. Let's look over here in the charge port area. 5 volts, 20 volts. And I don't think we're going to get any difference at one port versus the other right now, just because they're all doing the exact same thing. Now let's look. We can kind of see right there. I want to say that, actually I don't remember what that is off the top of my head, but let me see if it cools down when we unplug. Just a little bit. I want to say from previous experience that's actually perfectly normal for that side to get warm. Let's keep going. So we can see the T2 chip is getting warm. So it's getting power, but it's not actually turning on all the way. All right, that side looks okay. And we can still see the back side of the thermal imager, or on the T2 chip, is getting warm. That's perfectly normal. I expect that. So using the thermal imager, and that's our charging circuit, so that's normal. Using our thermal imager, so far, no obvious short. Okay. So there isn't any obvious short, in my opinion, that we see here on the actual board. So now I want to actually start getting measurements. What is our PP bus? And then there's a couple of power lines around the T2 chip we want to make sure are present. We may have to end up forcing this computer into DFU mode and forcing an update through. This one might not actually need a board repair, because it wasn't stuck in DFU mode, but that doesn't mean that the T2 chip isn't corrupt. It may still have to be connected to Apple Configurator and have the DFU revived. So let's check and see what our PP bus line actually is. And then while I'm at it, I'm just checking to see if anyone else was watching the stream right now. There's a couple of people watching. Thank you for joining us. And let's go back to the on-screen camera, or on-screen scene, they call them. All right, so the first thing we wanted to check, of course, is our PP bus. What is our PP bus line? PP bus is 12.3. That's pretty low, honestly, on this model. Just in case, I'm going to reboot the USB-C meter and see if it spikes or if it drops. And it looks like that we are still sitting around 12.3. And just to make sure that's not right, we're actually going to confirm that information with something. Because I would expect that we'd want something a little bit higher than that. Okay, so I just went ahead and pulled up repair.wiki. This is a great website if you're doing any type of repair. There's a lot of information for Apple repair. I want to say Tim from TCRS. I'm sorry if I'm butchering your shop acronym. He does a lot of information on here, and usually whenever I'm looking for PP bus, just because PP bus is all sorts of different power rails, I'd like to reference here to make sure that I'm not overlooking something. So let's see what we have here. We know that we don't have a PP bus short to ground. I'm just curious essentially what it should be, because I think I've seen on here where anything that is reading less than a certain voltage for PP bus is not right. And I don't really see drawing 20 volts, 0.1 amps. That's kind of similar to what we have, but we're 0.0, not 0.1. Which would help us because in this case this says that that's a dead SSD. However, we have right here no power, taking 20 volts, 0.014 amps. That sounds more in line to what we have, in this case PCH and PMIC, to do usually if the board is taking 20 volts, 0.01 amps to 0.02. There's a problem with the PMIC voltages, which is exactly what I was starting to rant on about. But I'm not seeing exactly what our PP bus line should be on this one. So, sorry about my ignorance. I don't necessarily remember off the top of my head what the PP bus is, but I feel like it's supposed to be around 12.6. Please correct me if I'm wrong. I'm just kind of learning on this one as we go. But 12.3 seems a little bit low. So now, let's just go ahead and check our T2 power lines and see if there's anything that's obvious bad. And all that information should be located, I think, also on repair.wiki. I know it's on logi.wiki, which is normally where I reference it. Let's see. What is this link that's actually associated to that specific issue? Well, this is not the same computer, is it? This is a photo of, I want to say, an A1707, so that's not the same thing. This is, yeah, it even says so right here, A1707. So that is not what we're looking for. We were looking at A1990, and I'm looking specifically for the T2 power lines. And I don't remember where that is located on here. So we're going to... We're gonna jump over to our logi.wiki. And we're looking for the T2 power on sequence for a CD3215. Here we are. And it just redirects anyways to the CD3217. Did we click on the right one? Hold on. T2 and CD3215 power on sequence redirects to CD3217 T2 power on sequence. And we're looking for the LDOs. I just forget what the names of all the LDOs are. And that's actually what this is even talking about here, is the specific LDOs. And where are they? For instance, I know like PP1V1 SLP DDR. I want to say that's one. But I want to make sure I'm looking at the exact thing. Aha, here we are. T2 power rails, that's just resistance. But these are the rails in particular that we want to measure, because these are responsible for actually powering on our T2. So let's go ahead and just kind of put this to the side while we pull up here on our schematics. And what we're going to be looking for, first one, whoops, why didn't that copy? Is our PPV DDD CPU awake? And it was DD, sorry, not DDD. That's that video game character from Kirby. Here we are. U3900 is our T2. U7800 is our power management chip for our T2. And we're going to look at these coils in particular and see what we are getting. So let's put our multimeter into voltage mode. Go back to the microscope camera and navigate over here to our power management IC. And let me try to get this in focus because it looks a little blurry on your guys' side. And what we're looking for is going to be these capacitors and coils right there. And let's check and see what voltage we are getting. That's going to be right here. And we're getting 0.7 volts. And that should be normal for that one. So let's navigate back to... Sorry, I need to get one of those hot... what are they called? Just one of those deck stations for quickly switching scenes. Where is my... Here we are. Okay, so now let's look at PP0V82 Sleep DDR. And we're still in the same area. We have a giant coil right here that we're going to inspect. And with my multimeter that you can't see, I'm getting 0.82. So that side seems to be working. Now let's look at PPVDD CPU SRAM underscore awake. It's a little further down in the corner of our power management IC.
There's no charge on this iPad, right?
Correct. But it does have a new charge port in there, because his old charge port was pretty beat up. Let's see. Sorry, I just had a question to ask. I lost my place. Oh, that's right. We're right here. So now we want to measure this specific line. And we have 0.8. So that side is working. Let's look at PP1V1 SLP SR S2R. And we have some coils here at the top of our power management IC that we're going to measure. And that's going to be this side. 1.1, which as the name of the rail entails, PP1V1 means we're supposed to get 1.1 volts. So, next one, PP0V9 SLP DDR. Back to our schematic. And that's on the right corner of our power management IC. And we have 0.9, which, given the name of the rail, PP0V9, that's correct. And PP1V8 sleep S2R. And still in the top right corner. Let's measure and see if that line is there. Given the name of it, PP1V8, we should have 1.8 volts. Okay, so that's going to be this one right here. 1.8. So it seems like we have all of our lines there for our T2. So I think we might, I personally don't see anything corrupted. So I think our T2 chip, the firmware on there might be corrupted as well. Let's see. Hi, will removing the T2 chip clear a locked Mac Mini 2020? Thanks, Open Inductor is a wild guess. Removing the T2 chip clear a locked Mac Mini. When you say locked, are you referring to EFI locked? Because that is a territory where it's a gray area. We're not allowed to discuss that area. Not curious. I'm concerned. I'm curious what you mean by that question. Sorry if that was a horrible response. But if it's EFI locked and you're not the original owner, unfortunately, I can't really help you out with that there. Back to what I was saying, though. I think our T2 chip here might be corrupted because the computer appears to be working like it should. We're getting 20 volts. 20 volts means that our PP3V3 line should be working. Of course, we can confirm, but I'm pretty sure in order for us to actually have PP3V3, we have to have, or in order for us to have 20 volts on our charger, we need to have PP3V3 working. And this one is a G3 hotline. And there's a couple places that it can be. So down here, let's check out this capacitor. And we can actually just use the overhead camera for that. How's it going, Tim? It's good to see you again. Okay, so it's in this area. Where is it, though? Yeah, 3.3 volts. So I figured that we were going to have 3.3 volts because we have 20 volts on all of our power lines. Our T2 chip seems to be perfectly fine too. So I think at this point we're just going to take an intermission. I'm going to put the computer back together and hook it up to our Apple configurator to see if this device is stuck in some strange T2 firmware. One thing we did see, if you remember, was that there was a little bit of corrosion on a capacitor that connects our PP bus, that is connected to our PP bus SSD line, and there was a little bit of oxidation or a corroded test point that is our 2.5 volt for our SSD NANDs as well. So there's a possibility, hopefully it didn't kill anything, but instead it locked up the oh, whoops, we got a rogue standoff. It locked up our T2 firmware, and this device just needs to be revived. No pun intended. That's just what Apple calls it, and I'm pretty sure I trademarked the name before they started using the term. So, Apple, you can mail me an envelope with some money in it. I'm gonna put this standoff back on first before I start putting this computer back together. But yeah, no obvious signs of shorts. Thermal imager looks to be heating up in the areas that would expect it. Only sign of corrosion I could see was that one test point. So this one may not actually need a full-blown board repair. And we want to connect all the proper connections. And I don't have Apple Configurator on my work computer, so I'm actually going to have to go to another computer. Oh, it would help if we actually had our charge port in our frame, because this side in particular is the ports we're going to need for programming this through Apple Configurator. So let's pull the board back out. How you doing, Tim? I haven't seen you in a minute. I hope business has been well for you. Optimized logic. Sorry. Optimized logic repair. He also is a board repair technician. He posts some videos as well. I think I've seen a live stream or two. No, you definitely do live streams. That's right. So if you guys are interested in board live streams, definitely check him out as well. I would argue that Tim is much smarter than I am, so he'd probably be able to fix boards in a quicker manner than myself. Tim says he's good and he has been busy. That's good. I'm pleased to hear. Okay, get all of our connections back in now that we actually have our USB-C board plugged back in. Oh, whoops. Rookie mistake. Ripped off the jaw connector. But I'm going to show you how we fix that. We get a lot of these from other shops. So here's our fan connector, and when I was plugging it back in, you'd see I just kind of ripped that guy off. So you want to make sure that your battery, of course, is unplugged. That way you don't bridge any connections. But it has two little wings right there. So what we have to do is make sure that this is facing up like this, and then we're going to slide that back into place over the pins. And we're good. I had a repair shop email me the other day saying that this was broken on an A1534. And they were going to ship it to us, and I said, please don't. This is something that you could probably do yourself. I don't know what's going on with our YouTube live stream, but it's showing the thermal imager that I did like maybe 10-15 minutes ago. Okay, let's see what else we need connected. It looks like all of our connections there. We obviously need the battery, so let's screw that back in place. And then we're gonna have to pay a little visit over to our other computer that has our Apple Configurator software, because I don't believe we have that on anything else at the moment. because Apple's constantly updating it, so we only really keep that ever on one computer. All right. And let me see if I can get this in a way to where you guys can see, and I don't think so because this tripod is kind of set facing this one particular way. So let me go ahead and hook this up to our other computer and check and see what we get. That's correct. Do you mind if I encroach on your area? Quick turn. Oh, not quick enough. All right, here is our Apple Configurator 2 computer. Don't think we have any customer data. Just gonna turn that over a little bit. What we'll need to do is we need both a charger and another Thunderbolt 3 cable. And we're gonna have to plug this to this 2017 iMac that has a Thunderbolt 3 port in the back. This one. There you go. And on T2 computers, we want to plug this into the port that is closest to the trackpad. So not closest to the screen, but closest to the trackpad. On M1s, it's the other way around. And now we need to get our charger. And you want to have kind of a high wattage charger. So I think this one here is a 97 watt charger, 96 watt, that's right. So now we're going to put this into DFU mode, and do that for 1 second, and then we're essentially going to do like an SMC for about 10 seconds. So we hit 1 Mississippi, 2 Mississippi, 3 Mississippi, 4 Mississippi, 5 Mississippi, 6 Mississippi, 7 Mississippi, 8 Mississippi, 9 Mississippi, 10. All right, so then now that that's done, we're going to open up our Apple Configurator. Which we have right here. And let's make sure that I mention that correctly about which orientation the T2 is supposed to be in, which port. And we're still not getting anything, so we're going to open up Apple Configurator 2, and we hit the power button, 2, 3, 4, 5, 6, 7, 8, 9, 10. And according to Apple Configurator, we're still not getting anything here. Again, just to make sure I'm not doing anything incorrectly. I realized, didn't realize I trapped you in. And let's check and make sure that we're actually connected in the back too. Still getting nothing. So it doesn't look like we can actually force this one into DFU mode. So that normally means there's still a short somewhere else on the computer, or something is potentially dead, like the T2 chip, for instance. We're not even getting a vibration on the trackpad, so that's not even being told to remotely turn on. Mississippi 4, Mississippi 5, Mississippi 6, Mississippi 7, Mississippi 8, Mississippi 9, Mississippi 10. all we're getting is that cannot use Thunderbolt accessory. May have to try a different cable in case there's something wrong with this one. Also just reboot Apple Creator entirely. And still nothing. So, just to make sure this isn't a matter of a bad cable, I'm going to get a different cable out.
Have a great day.
Okay, so I have another cable here. We're just going to plug it into the back of this iMac. That one more time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And still not getting anything.
Yeah, sure. It kind of looks cool though.
Okay, so this doesn't look like a situation where we can actually get this device into DFU mode. So, this one probably has a further issue with the actual T2 chip that we're not going to be able to repair. Which, if we go back to repair.wiki, there was an entry that did say that this specific voltage and amperage consumption can actually be indicative of an issue with the actual PMIC itself. Change back over here. And get this camera adjusted. Oh, look, it was saying some things. I'm sorry, not ignoring you, just trying to get some this working on this side. And timeout. Can reconfigure. Okay, let's grab our charger and our USB ammeter. Okay, we're back. Okay, so now that we're back, let's check and see one more time. Let's just kind of reference what was said on repair.wiki, because I think that information is going to be very similar to what we're experiencing right now. So this is logi.wiki, but here we are, repair.wiki. So what we were looking at right here is, in this case, platform controller hub, PP1V8 sus shorted. So let's check and see that real quick. Find out if this is shorted. Oops. So copy. And it doesn't look like this particular line or this computer actually has a 1V8 sus. Well, that's weird, because I want to say that was the board we were looking at here is the same one that was actually in repair.wiki. Let me make sure this is a... Yeah, A1990, which is what we're working on. Shorted PP1V8 sus. So this might just be a typo then. Let's look for something very similar to that name in the schematic itself. What do we say, 1V8 sus? Yeah, 1V8 sus. For suspended, not suspicious. Okay, doesn't look like we actually have that particular rail in here. Let's look. Because that might be for a different board. That might be for a 2019 board, while this is a 2018 board. Sorry, I'm just looking for U7800 to check and see all the different lines that go into it. And this is just kind of showing me everything that goes. These are just current sense circuits, which at the moment I'm not too concerned about. That is not what we're looking for. There's a lot to deal with U7800, so you can't just put U7800 to very quickly get to your power management IC. These are all things that just say place near. Where is U7800? Unless I missed it earlier. Ah, here we are. U7800. Okay, so do we have anything along the lines of that name? Because it was PP1V8 sus. PP1V8 sleep S2R, which we verified is there. And I don't think this particular computer has that. However, it would be something to do with the T2 chip. I would imagine that we could just measure in continuity mode around our PMIC to see if there's any obvious shorts. So, of course, the first thing we're going to want to do is make sure our battery is unplugged, because I did have to plug it back in to see if we could get this guy into a T2 restore mode, which was unsuccessful. Let's go back to our microscope camera. And also, while I have this pulled up, let's check and see if I have any other comments here. Oh, okay. Tim says that he likes my shelf setup with the oscilloscope and hot air. Thanks. I actually got this from IKEA. Okay, yes. Back to the microscope camera. And now that we're in frame, in the actual housing, I'm going to have to adjust the focus point. Okay. And now we're going to use our multimeter here and measure in continuity mode around the T2 chip and see if there's anything that is obviously damaged or obviously short. Well, we know that this line's actually a low voltage line, so that's actually okay. Okay, so we can't do continuity mode. We're just going to have to use resistance. And in fact, now that I think about it, hold on. Speaking of resistance, when we go back to logi.wiki, there actually was specifically a page talking about resistance on those power lines. Now, I did have power on all those, but let's check and see what the resistance was. That is specifically for a A2141, so that's not going to be what we're looking for here. Never mind. Disregard what I said. Sorry, just reading something else. Okay, never mind. So we are going to have some low voltages or low resistance on this, but I'm looking for something that is obviously lower.
Okay, yeah, thanks for letting us know.
And I expect to have this type of low resistance. Oh, sorry, that's right. You guys can't see what I see because I don't have my Bluetooth multimeter. But I don't have like a straight short. I have low resistance, and I expect that for these low of power rails. See, if we use continuity mode and we heard a beep, sometimes people could be under the pressure that or impression that that is a short. and that's simply not the case. It's just a matter of low resistance. Anything that has to do with like the CPU, for instance, is going to have low resistance. And just kind of quickly poking around the main inductors around here, looks perfectly fine. So I don't know if this is one that we're going to be able to fix, truthfully. My theory, and I'd probably have to get a second opinion, but my theory here is we did see a little bit of oxidation right next to our PP bus and our NAND. It is very possible that that may have killed something on our T2 line, because the NANDs on this one, the SSDs, they are actually controlled by the T2. The T2 is the SSD NAND controller, so that could have killed something actually from just a little bit of corrosion buildup in there. So I'm kind of running out of ideas personally. This would be the part actually where I would start asking other technicians on Discord to see if they had any insight on this, but I don't think we're going to be able to fix this one. I think we have ourselves here either a dead T2 or a bad power management IC, which I try to not do anything with that on this model. Well, just on these computers in general, it's just kind of a riskier repair in my opinion. And I'm sure there's other technicians that would say otherwise, but let me see if there's anything else that was mentioned in repair.wiki. Let's pull that up real quick. We need to, where's OBS? OBS right here, okay. This is just logi.wiki. I mean, this is not what we were talking about, but right here, this is very similar. Drawing 0.0 amps to 0.02, PP3v3, system on chip power management U present, but PPVCC prime core prime reg, and therefore missing PP3v3S5. I did check PP3v3G3 hot, but not PP3v3S5. Do not replace U7800, which is our power management IC. Instead, put device into DFU mode, which we already tried. Let's see, repair. The problem seems to be T2 not talking to PMU correctly. Note, you'll need a battery connected for this. 2019-16 model has the exact same issue. Well, this sounds similar. Another technician has documented. So let's just find out and see if we have PPVCC prime core underscore prime reg and see if that is present. And this is what we refer to as please bro. I'm just kind of looking up other information that other people have done because I'm running out of ideas personally. So right here in this general area of U7800, we have PPVCC prime core underscore prime reg. And let's find out if that's present. I need my charger connected again. So let me plug that in. T2s, man, they're a whole nother beast in themselves. Because it's not just the electronics that you're trying to repair. Need the battery plugged in. It's not just the electronics that you're trying to repair, but it's the firmware that is very temperamental, and if there is something that's off, it just kind of locks itself up and will prevent the rest of the computer from turning on. Because the T2 in this model is actually the replacement of the SMC, System Management Controller, of other computers. So it's kind of a cabal of things. It's the SSD controller board, it's also our SMC, and it'll just kind of not let power rails turn on if something is messed up with the firmware. So you're dealing with the electrical engineering side of the actual circuitry, as well as now the programming side of the firmware. It makes these a lot more time consuming to work on. Alright, so let's see if we are missing that rail as well, just to see if someone else has experienced something similar. And that's exactly what we got here. We are missing that particular line. What was it again? It's a very long one to say. PPVCC prime core underscore prime reg. We appear to be missing that, which, if that is the case, 5 times fast, if that is the case, then we're probably missing our PP3V3S5. Which, for some reason, is under a EADC2, because I think it's supposed to be underscore S5. That's what we're looking for. There we are. Whoops. These tiny little resistors right here are going to be connected to our PP3V3S5. So, do we have PP3V3S5? And it's a completely different way of thinking on these guys. You don't really have the luxury of just going through the power rails like we used to on other models where we looked at the power alias and then just kind of worked our way down on a list of rails that should be present. It's a different style of thinking altogether. Okay, so there is no resistors there, but the line is physically there, so we can still measure it and see if we have a 3v3, and I doubt we do because we were missing that one particular line. We don't, that is correct. Now, let's find out if both PP3v3S5 and that PPVCC prime core underscore prime reg, I think is what it was, is shorted. I doubt it. I think this is all going to be still corrupted T2, but in this case, I think this might actually be a dead T2 from the little bit of liquid damage we saw there. And we have 31,000. So that seems normal. And then let's go back here where that PPVCC prime core reg long name was at 31. I don't know if that's normal, just because I'm not familiar with that line. It is a line that is directly connected to our T2 chip, or our PMIC, so that might actually be normal for this one. PPVCC prime core. I want to say that's normal because it's talking about prime core, which is kind of makes me think of CPU, which normally has a very low resistance anyway, so I think that's actually normal. So,
Okay. So,
I don't know. I don't think we're going to be able to fix this one. I think this one's a dead T2 chip, honestly, which is unfortunate because with how these are also designed is that the SSD being controlled by the T2 chip means that we can't perform data recovery. At least I can't perform data recovery. I've seen other technicians who are far smarter than I am perform data recovery. I have not been able to do that yet. So, let's see. This one is not the same thing because we're getting a trackpad for about 20 to 30 seconds and then it stops.
His one's on the Asheville's on the 13th, and Charlotte's on the 31st. Yeah, it's at the orange deal.
Brain dead can be caused by numerous things. Any shorted subrail, which we looked at a good bit of the subrails. Thermal imager can reveal abnormal heating caused by shorted component. That is unfortunately not the case we have here. I wish the battery was not recognized. That'd be a much easier one. Yeah. I don't know. This one has me stumped, truthfully. So this one is similar to that of its counterpart, the 1989. Where is that one? There's not a page for it. There's only a page for the 2159. Which, we can just reference to see if a similar MacBook has had a similar issue. This one has a lot. It's talking about no backlight on display. Clean board. Current draws 200 milliamps. Not what we have. See, we're really reaching here. No power fluctuating. Usually a short to ground on a sub rail. Similar. Failed T2 or NAN. Device is not stuck in recovery mode. We don't have a short on PV3V3S5. But I do think we have a corrupted T2 or a failed power management IC. Resistance to ground on PP2 V5 NAND SSD 0 was good. Device is not stuck in DFE mode. We can't even get into DFE mode. Yep. This is all just talking about the power supply chip. And okay, I think that's it. How long have we been going on this one? Because I think we're gonna have to call it quits. We're an hour into it, and I feel like I haven't made any progress at all. And that kind of goes past my own time limit I have here of if we can't figure out an answer in roughly an hour, then unfortunately that's kind of the extent that I can offer here at this point, and would probably recommend a second opinion, maybe another board repair technician. But at this point, I can't see any obvious signs of shorts on the logic board. The board, except for that little bit of corrosion right next to the PP bus SSD to the 2.5 volt NAND SSD, kind of leads me to believe that at some point there was an event that took place, a little bit of humidity. I don't think anything was spilled onto the computer. I think a little bit of humidity buildup caused a static discharge event that may have actually damaged the T2 chip in the process. Specifically since we can't get this into DFU mode. So this is a situation where unfortunately we're going to have to tell the customer that we can't fix it. We work on a no fix, no fee basis for board repair, so we're not going to charge them for our time on this. But this is starting to become a reoccurring event with MacBooks, with T2s, is they can just randomly die. And it's really hard for us to troubleshoot, it's hard for us to fix. And this is just one of those cases where I don't think we're going to be able to fix this one. So probably not going to keep this board repair stream up because this was unsuccessful. I like keeping successful board repairs so that people can learn. Since this one was unsuccessful, I think I'm just going to have to probably take this video down. Or I'll keep it up as for things to look for when you're troubleshooting a dead T2. I don't know. You guys can let me know. I'll leave it up for like a day. And then decide if I'm going to keep this one up or not. But I appreciate you guys joining me. I haven't actually checked and see if there's any YouTube comments. Well, cool. Well, thanks for joining me, and hope you guys enjoy the rest of your week. This is a beautiful Monday, and I'll catch you on the next one.